Today we will talk about Book 4B, Chapter 12, more about basic properties of circle. So last time we talked about the relation between the radius and tangents. So if you got a tangent to the circle, we can always say that the tangent is perpendicular to the radius. And we also learned how to use the converse of tangents perpendicular radius to prove that whether the straight line is a tangent to the circle or not. And this time here, we will talk about the tangents from an external point. Okay, so we have a circle here, and then you got a point P, which we called a external point here because this point P is outside the circle. It's not on the circle, not inside the circle. And for every external point, we can actually draw two tangents to the circle. So no matter where is your point P, so we can still draw two tangents. And in here, we have a tangent at point A and a tangent at point B. So if we link those points together, you can see that we can actually create two triangles. And these two triangles is actually congruent to each other because your OA and OB is actually the radius of the circle, so therefore they are equal to each other. And then you have this OA and OB is the radius, and therefore it will be perpendicular to your tangent. And OP is the common side, so therefore they are congruent to each other with the reason RHS. So once we have this congruent triangles, we can say that the AP and PB are the same length because of corresponding sides of the congruent triangles, and then angle AOP and angle BOP are equal to each other as well because of your corresponding angles, congruent triangles, and then APO and BPO are the same as well. Those two angles again are corresponding angles to the congruent triangles. So these are the tangents properties. So we'll use this tangent properties to solve more questions later on. And be careful with that. Sometimes some of you might not be able to see it if the lines are not all drawn like this. So if some of the lines are disappeared and then it didn't show the angles, and perhaps this is the only thing you have got in your diagram. You got a circle and two lines linking to this external point P. So remember, this is actually an isosceles triangle because your AP and PB are same length because of the tangent properties. So therefore, if you have this isosceles triangle, you can use it to solve a lot of stuff as well. And sometimes some questions, your point P is very close to your circle. So some of you might find it very difficult to see that this is a tangent properties. So go back to your slides and then you can see this here. They show you how to prove that it is a congruent triangles using the reason RHS, and then tells you how you can say that those lengths are equal, but you don't have to write those every time. So when you recognize you got two tangents, TP and TQ are drawn from the external point T to the circle P at point P and point Q, then you can already tell me that those two lengths TP and TQ are equals, or the angles X and Y equals, or M and N is equals, just by writing the reason as tangent properties. So you don't have to every time prove that, oh, you got a congruent triangle, so therefore they equals each other. So now you understand this concept, then you can use it to solve your questions. So let's have a look at example 11 together. So AR and AC are tangents to the circle. So AR and AC are tangents to the circle, and you can see that both tangents are drawn from this external point A. And we'll erase the little part here because we just want to focus on AR and AQ first, because the external point is drawn to the circle at point R and point Q. So this is the tangents at point R and point Q. And therefore, we can use our tangent properties. Your AR and AQ will be the same length. And since those are the same length, and therefore you know this here is gonna be your isosceles triangle. So therefore, your angle RQ is equals to angle AQR. So once we got all those info, let's have a look at what they asked you. So they want to know what is your angle RQP. So where's angle RQP is here. So what else do we know? We also know that is here is 44 degree and this one is 26 degree. And by looking at your angle RQP and the information next to it, this is a straight line, so we know that they add up to give you 180 because of adjacent angles on straight line. And we know that one there is 26 degree, the angle PQC. But what is this angle AQR? Because it's the isosceles triangle, and you have one of the angles already, so you can find the third one using your base angles isosceles triangle. So therefore, we have all the information you need, and we know how to write the flow out. So let's write out now. So AQ is equals to AR, and you have to write tangent properties for this one. Okay, and because of these two lines are equal, so your AQR is equals to your ARQ because of your base angles isosceles triangle. You can see that every time before I write out, I go and have a look what they ask and look at what information can help me to find it. So I'm doing a backward or a reverse process, and then I start writing out the stuff. So angle sum of triangle for this one. So two of those angles adding 44 degree equals 180. And then therefore AQR is your 136 divided by 2, which is 68. So angle AQR adding angle RQP adding angle PQC equals 180 as well because of adjacent angles on straight line. So make sure you write the reasons every time so you know what you're doing. So 68 plus angle RQP plus 26 degree equals 180. So therefore, angle RQP is equals to 86. Okay, so here you go. So therefore, this is your first part. And then second part. Okay, so second part here, they ask for RSP. So where is your RSP? So let's have a look at your RSP. Maybe I should use another color. Okay, so RSP, where is that? So this one is your RSP. So seems like it's not close to the information here. So all your information is down there. So what have we learned recently? So what kind of shape is this? So this is a quadrilateral, and this quadrilaterals, all the vertex are lying on the circle. So therefore, this is a cyclic quadrilateral. And for cyclic quadrilateral, we know that the opposite angles add up to give you 180. So therefore, RSP adding RQP is equals to 180 because of your opposite angles cyclic quadrilateral. And RSP adding 86 degree, which you have found just now, equals 180. So therefore, angle RSP is 94 degree. So let's have a look at example 12. So AB, BC, and CA are tangents. So let's have a look at this. So this here is tangent, this here is tangent, and this here is a tangent as well. And then it says if AOB is 125, find your ACB. So where is ACB? So this is ACB here. Okay, And you can see the only information you got here is this 125, as in this triangle here. So have a look at this triangle. Okay, so we don't have the other two informations, the angle OAB and the angle OBA here. So if actually have a look at this now. So what did we know about these two angles? Do we know anything about these two angles? So just now when we draw it, there's so many tangents, but if we look carefully, instead of looking at all those tangents, let's look at this two first. So if these two are the tangents, then we can use tangent properties because these two tangents are from the external point A here to your circle point Q and point R. So for tangent properties, what do we know? These two angles are the same, isn't it? So these two angles are the same. And then let's look at the other side. Same for this one. If this is the tangent, then using the tangent properties, these two are the same because this time these two tangents are created from the external point B to the circle point P and then point R. Okay, so we know that these blue angles are the same, these red angles are the same. What else do we know? So our only information about the angle, the size of the angles, is this 125. And by looking at this, this is inside this here. So this triangle add up together should be equals to 180, isn't it? But we don't know what's the angle, the red angle and the blue angle, but doesn't matter. So let's have a look at this first. We know we somehow want to find these adds up together with this one because this is what you want to know eventually. So we can start with the triangle OAB first. So easy to write, so we let the unknown first. So once we let the unknown, you can start writing. In the triangle OAB, we know that A plus B equals, A plus B plus that 125 equals 180 because of an angle sum of triangle. And then therefore, you can find your A plus B is equals to 55 degrees. And just now we said this two red one is equals to each other because of your tangent property. So angle QAO equals to A because of your tangent properties. And then angle PBO equals B because of your tangent properties as well. So now we can find our angle ACB because this here is a triangle. So every angles inside add up to 180. So in angle triangle ABC, angle ACB, adding angle CAB, adding ABC, she equals to 180 because angle sum of triangle. And then angle ACB adding. So take a look at this here, your angle CAB. So it's a little bit messy here, but you can see this angle CAB is this angle A and this angle A here. So A plus A, and then the other one is here, this two here, so it's B plus B equals 180. So therefore, angle ACB plus 2A plus 2B equals 180. Then you'll think, how do I find it? Because I have two unknowns. But remember, if we take out the 2 as a common factor, you got this A plus B. And we have found that A plus B is 55 earlier. So therefore, angle ACB adding 2 times 55 degree equals 180. Angle ACB is equals to 70 degree. So the previous examples are all asking about the angles, and you can look at this example 13 here. It's ask about the length AX. So in here, AB, BC, and AC are the tangents. So all these are the tangents here, right? And then they give you some of the lengths, the AB, BC, and AC as well. And they ask for AX here, so this little part here. So in here, let's let this unknown x. So let your AX be x. Okay, so what do we know about this x here? So these are the tangents. So again, erase the little part here. So let's look at this part here first. So if we have an external point A and we draw the tangent to the point x and z of the circle, then we can also say that AX is equals to AZ because of your tangent properties, isn't it? And then also, if we said this is your, if this is XCM, then therefore this part here is 11 minus XCM. And of course, for the same, this part here is your 14 minus XCM, isn't it? And then we also know that, so use this color, because this is the tangent from your point B, and therefore this length here is the same as this length using your tangent properties. So this BY here is 11 minus XCM as well. And again, if we look at this tangent here, this time this tangent is from your external point C. So this part here should be the same length as that, and therefore this is your 14 minus XCM. And if we know the total length, then obviously we can set our equations ourselves. So let's write out what we have so far. So we have this Bx equals AB minus AX, which is your 11 minus XCM. Remember, whatever you draw on the diagram telling me those 11 minus x or 14 minus x, you have to write it out and say why. So don't expect me to look at your diagram. So by is equals to bx because of your tangent properties. And therefore, 11 minus xcm. Az is equals to ax because of your tangent properties. And therefore it's equals to xcm, so cz is equals to ac minus az, 14 minus xcm. And then your cy is equals to cz because of tangent properties, which is 14 minus xcm. And you can see that BC is equals to BY plus CY. Okay, so this part here. And therefore, you can say that 15 is equals to 11 minus x plus 14 minus x, and 10 is equals to 2x, so therefore x is equal to 5, and therefore length of AX is 5 cm. So this is the questions of using your tangent properties to solve the length. Let's have a look at your consolidation exercise 12D. So turn to your question 5. So in this question here, they want to find the unknown d. So what do we know about unknown d? So d is here, and what do we know about it? So it is next to that triangle ATB, but it's not an external angle of that triangle. So what else do we know? We don't have any parallel lines, we can't find it. And we know one thing here. So this line BT is the tangent, and then this OB is the radius. So tangent and radius, we know that it is going to be perpendicular. So this here, OBT is 90 degree because of tangent perpendicular to radius. But we do not know what is our angle ABT. So therefore, we have to figure out a way to find it. So what is this angle ABT here? So we just said we have a tangent BT, but we actually have an other tangent here, AT, isn't it? So if both of them are tangent from the external point BT, then we know that this length BT and TA is gonna be equal, and therefore you have the isosceles triangle. So this angle here will equals to this angle here. And once you got that, and you know that is actually a 90 degree, then you can find your angle D there. So let's write it down. So because this length here is equal to this, tangent properties, and therefore the base angles are equal. And we said that this OBT is equal to 90 degree because of your tangent perpendicular to radius. So make sure you write this out so that I know where is that 90 degree comes from. Do not just jump to this line saying OAB plus your ABT equals to the 90 degree without telling me why that OBT is 90 degree. So therefore D plus 56 is equals to 90 degree, and D is equals to 34. Okay, and let's have a look at your question 7. So question 7, they asked to find the unknown F. So F here, what do we know about F? So your information given is on this side here, and it's a bit far from your F. And have a look. F here is the external angle of the triangle OBT. And what do we know about the angles inside this OBT here? So again, we got the tangents here. AT and VT is the tangent, and therefore we know that somehow we can use our tangent properties. So for tangent properties, this time we can say these two angles are the same. So if I can say that these two angles are the same using tangent properties, and I can find, if I can find this here, OBT, okay, if I can find this angle OBT, then I can find the external angle of triangle, which is your F. And what do we know about OBT? You can see I draw that 90 degree there already. Why? Because BT is your tangent and OB is your radius, so tangent is perpendicular to radius. So therefore, let's write it down. So tangent properties, and then your tangent perpendicular radius, and And therefore, using our external angle of triangle, we can find F there. So F is equals to 118. Okay. So if there's no questions, let's have a look at question 9. Okay, question 9 here. So this time in this question, you have to find H. And you can see this very obvious. You got this parallel line, and then therefore we know that this one is also 72 degrees because of your alternate angles CA parallel BT there. Okay, so once we know that this 72 degree, and you can see that is closer to your unknown H already. And then let's look at what other stuff we know. So this line here, other than that parallel line, is also a tangent, and AT is also a tangent from this point T, external point T, and therefore using our tangent properties, AT is equals to this BT here, and therefore this is your base angles isosceles triangle. They equals each other, and when you got two angles in the triangle, you can find the third one, H. So write down again. So once you got the idea, just write out. And of course, when you write out, make sure it's in the right order. So because you found this is 72, and then you can say that TA is equals to TB verse using the tangent properties. And then you can use your base angles, isosceles triangle, saying that it equals to 72 as well. And then in triangle ABT, they add up together. All the angles add up together, give you 180. So 72 plus 72 plus H equals 180, and H is 36 degrees. Okay, so question 10, I'm not going to do question 10 because question 10, if you look carefully, is very similar to the examples we have just now. And same for 11, is very similar as well, using the informations they give you using the tangent properties to find the third length. So how about let's look at question 13. So question 13, you got the three tangents, PA, AB, and RB, and then they ask you to find the angle PQR. So let's look at where's your PQR. So this one is your PQR, isn't it? So it seems like we don't have other information, but let's look at your information. So you got one information here, you got one information here, but it's nothing close to that PQR we want to find. But if we look closer, okay, so we got this tangent here, isn't it? Right, this is the tangent. So AP is equals to AQ. So we know that these two are the same length because of your tangent properties. So therefore, this is your isosceles triangle here. So therefore, the base angles are going to be equal. So now, if I can see that this 58 degree from angle AQP is closer to the things they want you to find, the PQR, then maybe I can try to find the angle next to it as well. Here, the angle RQB, because I know that this is a straight line here. If I can find that angle, then I can use adjacent angles on straight line to solve it. So do I know what is your RQB here? I think I know what is your RQB here because this is another tangent. There's another tangent here. So these two are the tangent. And again, BR and BQ are the same length, and therefore these angles are the same. So let's show you this angle and this angles are the same. And how do I find these two angles? Because I got a 76 there, so therefore I can find those two angles. So therefore you have an idea in your head and write it down. So start with this. And then these two angles are equals. And then another tangents. So tangent properties. And then again the isosceles triangle. But this time you don't have the size of this two, any of those. So therefore you have to find out using the third angle in that triangle. So which is this here. You add them together to give you 180. Because of your angle sum of triangle. So 76 adding 2 of the BQR equals 180. So then for angle BQR is equals to 52 degree. And they're all on a straight line, so therefore they add up to 180 again. So 58 adding PQR adding 52 equals 180. So angle PQR is equals to 70 degree. Okay, so then look at part B. Part B this time, they want you to find what is PSR. So where is PSR? So let's have a look. PSR here. Opposite here. So this again is very far from whatever information you got down there. Okay, but what else do we know? So this shape here is a quadrilateral, and all the vertex is lying on the circle, and therefore this is a cyclic quadrilaterals. And then therefore we know that the opposite angles add up together give you 180. So PSR adding your PQR equals 180. And that's your opposite angles cyclic quadrilateral. And therefore PSR adding 70 degree equals 180. Angle PSR is equals to 110. Let's look at question 17 here. Two circles intersect at 2 points, PQR and then RS are the points on the larger circle, such that PS and QR are tangents. So these are tangents, highlight the information, and if PSR are 43 degree, find your PTQ. So where's your PTQ? So let's have a look. This is your PTQ, and just now it says it's PS and QR are tangents. So this is PS, QR tangents to this small circle. So therefore you know that the lines, we don't need to look at such a long line here. Okay, so all you have to do is recognize that T is your external point, and then it is the tangents that hits at the point P and Q for this small circle. So therefore, using our tangent properties, we know that PT and QT are the same length, and therefore, if you can't see, I can zoom in a little bit. And see here, we actually got this small circle. Maybe yellow is not a good color. So we got a small triangle here. Okay, so PTQ is a small triangle. So here, what do we know? If this is same length, these two angles are gonna be the same. Okay, if we can find this two angle, then we can find our PTQ. But the thing is, how can we find this triangle? Find this angle. So if we look carefully, the information we have is here 43. So how are we gonna use it? So this shape here, you should be very familiar already. So just focus on this red one here. So this kind of like a butterfly shape. You got a 43 here, and therefore this angle PSR is gonna equals to your angle PQR because of your angles in the same segment. So that one is 43, and because of base angles isosceles, the other one on the other side is also 43. So therefore, using angle sum of triangle, you should be able to find your PTQ. So write out now. So angles in the same segment. And then it's 43 degree, and because PT is equals to QT due to the tangent properties. So you got this base angles equal to each other, which is 43 degree. And in triangle PQT, so again, the triangle looks a little bit small, but if you look carefully, you can still see it. So this triangle, all the angles add up together should equals to 180. So angle sum of triangle. So 43 and 43 because they're the same angles. And therefore, angle PTQ is 94 degree. Okay, if there's no question, we move to our 18. In 18, this figure, TA and TV are the tangents to the circle at point A and B. If angle APB is 115, find BAT. So where's BAT? BAT is here. So the only information is that angle at the circumference. And what do we know about that? Angle at a circumference is twice the center. So angle at the center is twice at the circumference. But the thing is, we don't have a center here. But that's the only thing we know about the angles at the circumference. So therefore, at this point, we have to create our center ourselves in order to use that information. So let's draw this center ourselves. So with the notation, but this time make sure you write a little bit more. Let O be the center, because it's really hard for me to see what kind of notation you have to draw if you just suddenly plot a point inside the circle. And I have also joined my length OA and OB. So once I know that I got a center angle that's centered, which is twice at the circumference, so therefore it means that which angle I can find? I can find this one here, which is your reflex AOB. So maybe you write out first. Equals twice the APB. So sometimes you have to draw something if you can't use the information. and you got 230. And then here, what do we know that part, but it's not helping you at all. So how do we use it? So have a look in here. So this is the angle you're trying to find, isn't it? And if I want to use it, let's have a look. This is a tangent, right? And just now this line we draw is what? Is your radius. So we know that the tangent and the radius perpendicular each other. So it's 90 degrees here. Okay, so if I can find this angle OAB, then I can use that 98 degree to minus it. But how do I find that OAB? So we use another color, easier to see. So this is a radius. This is also a radius. So therefore, these two angles should be the same, isn't it? So meaning that if I can find this angle AOB, then I can add up with those base angles OAB and OBA to give you 180. So can we find angle AOB? Yes, we can find angle AOB. Why is that? Because angle AOB, adding that reflex angle AOB should equals to 360 because angles at a point. So therefore, angle AOB adding this 230 give you 360, and angle AOB is 130. Okay, then we can say that because OA is equals to OB because it's a radius, therefore angle OAB is equals to your angle OBA. Base angles are isosceles triangle. So you can see that we always use this to help us to find the informations we want. And once we have that, we can say that all the angles inside this triangle OAB add up together will give you your 180. Angle sum of triangle. So 130 adding to OAB equals 180. So angle OAB is equals to 25. And just now we said OAT is 90 degrees because of your tangent perpendicular radius. So make sure you explain all this so that I know which theorem you're trying to use. And therefore, your angle BAT is equals to 90 minus 25, which is 65 degrees. Okay, and then the next part, it says, I want to find your angle ATB. So have a look at this. Let's cut this diagram first so we can use it. Okay, so ATB, where's your ATB here? So ATB is this one here. Right? And how can we find it? So again, these are the tangents. So AT and BT are the tangents. And with the tangent, what do we know? These two lines are the same length. So how about write out first because the diagram is a bit messy already. So tangent properties. And we know that if these are the same length, then we have this angle A and angle B, which is your angle ABT equals angle BAT, because of your base angles isosceles triangle, right? And we just found that, which is your 65 degree. And once we have that, this is a triangle. So everything inside this triangle add up to 180. So angle ATB plus angle BAT plus angle ABT equals 180, angle sum of triangle. So angle ATB, adding 65, adding another 65 equals 180. So ATB is 50. Have a look at question 28. So TP, TQ, and AB are tangents to the circle. And then it says AT is 29 cm, BT is 21, the perimeter is 70, and find the length of AP. So what do we know about AP? So AP, if we look closer, okay, if we look closer to your AP, this line here. So if this point here is the external point, and then you can see actually AP and this AR are the tangents, isn't it? Okay, so therefore we know that this is a tangent, and then what do we know? We're talking about the length, isn't it? So therefore, if we let an unknown x here, if AP is x, AR is x as well. Okay, and then therefore, what do we know? What else do we know? So this part here is 29 plus x cm, isn't it? And we zoom out a little bit again, and you can see this TP here is actually the tangent, and TQ is a tangent as well. And therefore, what does this TQ equals? This TQ equals to your TP, right? And therefore, this one here should equals to the 29 plus x as well. But do we know what is our BQ here? So we know that BQ, okay, so I use another color, BQ and BR are actually both the tangents drawn from this external point B. And then therefore, for BR, we know that it's going to equals to your BQ because of the tangent properties, isn't it? But the thing is, there's too many unknown here. Do we know what is your BR actually? BR is actually your AB minus AR, isn't it? So we want it in terms of that unknown. But the thing is, I don't know what's AB as well. But if you look at the other information they provide, TAB is 70 cm. So okay, start getting a little bit confused, so let's write down. Perimeter. We haven't used this information yet, so perimeter TAB equals, what is it equals? Your AB plus AT plus BT, isn't it? And then it means that 70 equals your AB plus AT, which is 29, BT is 21, and therefore AB is equals to 70 minus 29 minus 21, which is 20 cm. So if I got AB is 20 cm, and then let X be AP first, and then we know that your AR is equals to AP. Make sure to write out again, things on this diagram cannot just draw it out like this. You have to tell me that why those equals each other. I mean, the only thing you let is this AP. So make sure you have to write the others as well. You can't just draw on the diagram that AR is also X, and then you assume that I know Y. So you have to write it's because of your tangent properties there. So BQ equals BR, and then BR we have it now because we know is AB minus AR, which is 20 minus 6. Try to put everything, okay, this is tangent properties as well. Try to put everything in terms of one unknown only, because you don't want so many unknown in your question, isn't it? And once we got that part, we got your TP equals TQ, which is your tangent properties as well, because you have so many tangents in this diagram, so you can use it. So therefore, we can now join them together. Your AT plus AP is equals to BT plus BQ, isn't it? And therefore 29 plus x equals 21 plus 20 minus x. And therefore you have 2x equals 12, x is 6, so therefore length of AP is 6 cm. And then the next part says find the radius of the circle. So how do we find the radius of the circle? So in order to find the radius of circle, so we have to actually draw this here first. So let's draw this center O here. Okay. So with the notation, and again, you can just write with the notation this time, because you have to tell me what is O. O is the center. Let O be the center of the circle, because if you don't write that, I would just thought it's just a point on the circle. And then I join the line OQ and OR as well. So therefore, the thing is, I have to find my OR or OQ. Both of them are the radius of the circle, so it doesn't really matter if you find an OR or OQ. But the thing is, how do we find it? Do we know anything about that? So we do not know what is that length yet, but we know that this is a radius and this is a tangent. This is a radius and this is a tangent, isn't it? So therefore, we know that ORB is equals to 90 degrees because of tangent perpendicular radius. And then this OQB is also 90 degrees because of the tangent perpendicular radius. But the thing is, you still don't know what is the length of the radius. What is the point of showing all these tangents perpendicular radius? You can see that when I draw this, when I highlight this radius and the tangent here, okay, maybe use this green color. When I highlight this, what kind of shape you think it is? It looks like a rectangle, or it looks like a square to you, isn't it, when I draw it out? But remember, this is only when you draw it. It looks like, but it didn't really say it's a rectangle or a square. But if I can show that it is a rectangle, then you know this length OR here is gonna be the same length as BQ. BQ is just this 20 minus x. Sorry about that. 20 minus x. Okay, ignore this. This is for TQ because. So we only have, if we can find out this is a rectangle, then we can say that OR is equals to that BQ, which is your 20 minus x, isn't it? But the thing is, how can we prove that is a rectangle? So we prove that angle ORB is 90 degrees, angle OQB is 90 degrees, but we have to prove the other two angles is 90 degrees as well in order to say that it's a rectangle. So how can we prove the other angles? So this here, okay, so the diagram is a bit messy, but I hope you can still see it. So this here, if, okay, you can see that this line is 29 and then this one is 21, right? And we have found what is AB as well. So if we can prove that this 29 square is equals to this 21 square plus this AB square equals to that, then you can say that this is a right angle triangle because of your converse of Pythagoras theorem. If this side is a right angle, then this side is a right angle as well. So therefore, this BQOR is a rectangle. So therefore, the next part we have to prove is this AT square. So AT square is 29 square equals 841 cm square. AB square plus BT square is equals to 20 square plus 21 square, and is equals to 841 cm square as well. So therefore, you can say AT square equals AB square plus BT square. Therefore, angle ABT is 90 degree. Converse of Pythagoras theorem. And therefore, BQOR is a rectangle. And therefore, radius of circle is equal to OR equals to BQ and equals to 20 minus x, and x is 6, so therefore it's 14 cm. So let's look at example 14. So you got a diameter of the circle, and then you have this length AB and AD touch the circle at point B and D. So therefore this is actually your tangent, isn't it? And then they ask you to find the length of DC, and the other information they provide is your BC is 15 cm and then the perimeter is 40 cm. So you have some length and you want to find another length. So therefore you have to make use of it. So instead of me writing it out, so let's have a look at this. So if we got this as 15 cm, the BC as 15 cm. So what else do we know? We don't know what is your BA. We don't know what's your AC, but we know that it adds up to give you 40, isn't it? But this other information is your tangent. So if you know their tangent, using tangent properties, you know these two parts are equal, and therefore if we put it back into here, we can make AC in terms of x. Okay, so that's the first thing you want to do. And then after that, you want to use your Pythagoras theorem to find x. But in order to use Pythagoras theorem, we have to show one thing first. What is that? You can only use Pythagoras theorem if you got a 90 degree or right angle triangle. So therefore, again, we can use the tangent and radius to help you to show that this is a right angle triangle. So this is the tangent and this is the radius. Okay, so therefore tangent and radius is perpendicular to each other, so therefore you can use your Pythagoras to find what is x. So put your AB square, BC square, and AC square in terms of x, and then you'll find that x is 8. And once you got x is 8, remember the part you want to find is DC. So DC is actually your AC minus AD. And then remember AC, you have make it in terms of x, which is 25 minus x. And then you know what is x, so you put it back into this here, you'll find that your DC is 9 cm. And then they have this part B asking you to find the radius of the circle. So let's have a look at that. So how can we find the radius of the circle? So the radius in here, you have to, it's too dark. So you have to draw it out first and let O be the center of the circle. and then join the line OD here. Okay, so what do we know about this radius OD? So the radius OD here, we know that is a radius, so therefore this is a tangent and a radius, then you will have this ODC as 90 degree because of tangent perpendicular to radius. And this kind of shape, you can kind of remember it, is always a similar triangle. So before you know how to write this, let me show you why is it a similar triangle. So we have this here is perpendicular, we just prove it. And in the previous part, we also say that this one is perpendicular because again is a tangent and a radius. So we got these angles are the same, and then angle C here is a common angle. Okay, so we got a 90 degree and a common angle for both of the triangle, and then the third angle is gonna be the same. Why is that? Because angle sum of triangle. So you got a 90 degree and a common angle for both triangle, then therefore the third angle has to be the same as well. So therefore you have a similar triangle. Once you have this similar triangle, you can use the ratio to find the radius because you got the other length already. So OD is the only unknown, and you can solve it using your ratio. Because remember, in a similar triangle, the sides, the ratio of the sides are equals to each other. So then here is the last thing I want to talk about. I mean, you can have a look at this alternate method as well. So the next thing I want to talk about is a common tangent. Okay, we got a new term called common tangent. What is a common tangent? So we talk about common side, common angles when we talk about similar triangles or congruent triangles, right? So a common tangent is just a tangent that you share with two circles. So a straight line L in this diagram here is a tangent to the two circles. And then this the case below is also a common tangent of two circles. So when there's a straight line touching two circles at the same time, that is your common tangent. So let's look at the last example I will be doing in this video. So in this figure, PQ is a common tangent to the two circles with center A and B. So AB is 20 cm, AP is 15 cm, and BQ is 3 cm. Find the length of PQ. So PQ here. Okay. So PQ, what is so special about this PQ here? So look carefully. This is a straight line touching the two circles, and at one point, so two circles P and Q are touching, and therefore this is a common tangent. So what do we know about common tangent? So if it's a tangent, this is the radius. We got 90 degree on this side here, and then therefore we can use this to find your length. But how can we find length? This is a trapezium. Okay, so therefore we'll draw a line to help you to do this. If we construct a line here, so let this point C be a point on AP such that BC perpendicular AP. Okay, when you draw a line or point, make sure that it's useful. And then also we just said that PQ is a common tangent. So therefore, AP is perpendicular to PQ, and then BQ is perpendicular to PQ, and all this is tangent perpendicular radius. And therefore, PQBC is a rectangle. Okay, so once we prove that is a rectangle, we know that the opposite length is equals, opposite sides are equals length. Okay, so once you have that equal length, we know that AC is equals to AP minus CP, which is 15, and CP is 3 because it's equals to BQ, so it's 12 cm. So you got this ACB, this is 12 cm, and what is your CB? So can we find CB? Yes, we can find CB. How do we find CB? So CB here is equals to this because of your Pythagoras theorem. And then we know that AC is 12 cm square, so minus 12 cm square here. But what is AB? So AB is given here, so this is 20, so therefore 20 cm square minus 12 cm square, and then we have square root, and it's equals to 16 cm. So, and PQ is equals to CB because it is a rectangle, so therefore it's equals to 16 cm as well.